Hello. This is a little guide on making Gecko or AR codes for custom Robo modding. So go ahead and open the game, open Memory Engine, and open up the memory viewer. So we'll start with a simple code for updating a value on a Robo, and we'll do a code to give Ray 200 down. So the first thing we need to do is locate the down value. To start, use this memory addresses document. This shows the memory addresses for all the parts in the game and some other more advanced stuff, which you don't need to worry about right now. So we'll take this memory address and paste it into memory viewer. Then in order to know where the down is in all this data, you can look at the byte map. So this, conveniently enough, is for Ray 01. So there's some landmarks here which may not be present when looking at other Robos. But we can see there's this string of numbers, then like a row and a half of zeros, then there's some numbers and some more zeros, and then we get into the main chunk of the data here. And there's this set of 64s at the end of the first line. And the down is over here at the beginning of the first line. And since it has this yellow box, that means that both of these values together contribute to the down. It's called a half word when it's made up of 2 bytes. So if we want to set a value in RAM to a particular value, we use a direct RAM write code. This site is extremely useful. It lists a lot of different types of Gecko codes used for increasingly advanced things. But the simplest are just these direct RAM writes, which just write a value to an address in the RAM constantly. Since we're writing to a value that has 2 bytes, and each byte is 8 bits, we need this 16 bytes write. So this starts with 02. Let me open up VS Code. 02. Then this underlined bit is the address that we're writing to. So let's see, what's the address we need to write to? So this is the start of Ray's data. The address here is 801C6C84. If I type that in, then you can see this 03E8 jumps to the top. So this is the address that we're writing to. We can't just paste this like this, because AR and Gecko codes need to be 8 digits space 8 digits per line. And this would be 10 digits. So what we do is we just chop off the 80, since this indicates that this line is an address. So we chop that off and we put it here. And now this line means write 2 bytes to this address. Next, we need to specify what value we're writing to. So the Y's are how many addresses we're writing to. We're only writing to 1 address, so we just put zeros here. Then the value that we're writing, we said we wanted to put 200, but we need to convert that to hexadecimal first. So go over here, convert decimal 200 to hexadecimal, which is C8. We need to write C8, but this line needs to be 8 digits, so we'll put some zeros at the beginning, then C8. So now this code will write C8 to these 2 bytes at this address. So test this out. Close the game. Add a Gecko code. Paste the code into the code box, save, make sure this is active, and also make sure that cheats are enabled in config. Let's run the game. Okay, no part select. Go to practice mode, and we get down by a standard bomb. I don't think standard bomb does like 300, 350 down, something like that. But the easier way to check is just look at the memory address, or the value of memory in memory itself, and we can see that it's set to 00C8. And a fun quirk with this direct RAM write, it's writing constantly to this address, so if we try to change it, it just gets overwritten immediately. But yes, that's a simple RAM write Gecko code. So now let's go over how you can make a slightly more complicated Gecko code. So I'll do something that's similar to the swap robos code that I made. The full thing is like a little too long, so I'll just make something that swaps just the robos and not the full build. So what we want to do is when both robos are secret, press Z and X on either robo to swap the robo to the other side. So what we need to do first is check when both robos are secret. If we go to the memory addresses document, there's some addresses written down which are flags for when a particular robo is secret. So what we need to do is check these addresses. Copy this. We can see it's 0004 while the red robo is normal, and then it switches to 0 when this robo is secret. Okay, so we need to set up a code that looks at this address and checks the value. And this is done with if codes. So this is 2 bytes. Each byte is 8 bits, so we'll use a 16-byte if. And we want to make sure that it's equal to 0000, so we'll use an if equal. So 28 is the code type for 16-bit if equal. Then we need the address, excluding the 80. If 16 bits at base address and not this. This. Okay, so this part is something to do with the address. We don't need to worry about that. We can just directly use the address here. So keep these as zeros. Then the XX, the value that we're trying to check, we go back to the game and memory engine. We want it to make sure that it's 4 zeros. So checking if this address is equal to this value. Well, we need to check the other robo as well. Let's go back over to the memory addresses document. The blue robo secret flag is over here. So I'll just copy this line and update the address here. That. We can double check when the blue robo goes between secret and normal, this value gets set to 0. Okay, cool. So now we need to also check the input. We can look at the controller inputs at this address. So we go over to here. You see different values correspond to different numbers, but we can also just test. If I hold down Z and X, we can see that this address gets set to 0410. So we need another if equals at this address to 8 this. It needs to be equal to 0410. So now what we need to do is copy the robo from one side to the other. In order to copy this value, we need some address to copy it into. And Gecko codes allow us to use something called Gecko registers. And this is basically just portioning off parts of the memory to use quickly with these particular Gecko register codes. So the first thing we need to do is set a Gecko register to a particular value, space in memory. We can use the spot in memory where the story mode dialog gets stored. What we need is this Gecko register code. So BA base address in this case is at the very top of the memory viewer, this 8 with 7 zeros. So what we can do, since we're using this address and we're using this code, which is base address plus whatever we're putting in, is use this but with a 0 instead of an 8. So this is the address where we're going to set the Gecko register to. Then use this to make this code set a Gecko register. And then the register that we're setting will make it the 0th register, indicated by this 0. So we'll have this be the register for the red robo, and then we'll make another register on the next line, 8580, because 9 is this line, A is the next line. And this will be for the blue robo. So the next thing we need to do is do a memory copy. First, we'll use this code to copy from an address into a Gecko register. Then we'll use this code to copy from the register back into the address. first we'll copy from the player 1 robo into the first register. So the player 1 robo is at this address. Go over to here. See that it's 0, 1, 2. So copy from this address into register 1. Look at the documentation. Copy this many bytes. So first we start with the code type. Then we're copying just 1 byte. F. And then the target register is register 0, which is the same number we put up here. Copying from this address. Then we'll copy the second robo, which is at this memory address. Double check this. Yep. Okay. This is going to be a very similar line, but we're copying into register 1 here. Yes, this is all the same. Then we copy into a register, copy 1 byte, copy into this register. Next thing we need to do is copy from these registers into the memory. So we'll use this 8A code type. 8A, copying 1 byte. So we'll copy first from register 1 into the Robo 1 address. Then copy from register 0 into the Robo 2 address. And the last thing we need to do is end these ifs. So if you scroll back up to the 60-bit ifs that we used, we see there's this end if, and this indicates that we have to close out these if statements with an end if, which shows the code handler. It lets the code handler know what these if statements are governing, which lines are supposed to execute when these conditions are satisfied. If we don't end this if, then any code that comes after this, so in other words, like any codes that are after this code in the list, like if we do this, all of these codes, these will also only execute based on the conditions in whatever code that we're using. So we have to be careful to end these ifs. And the way this is done is with a terminator. And we can just use a full terminator. If you want to be very particular about ifs, if you're using multiple ifs like in different sections of code, then you might need to use this end if to end like a particular number of ifs. But if we just use a full terminator, then that'll completely close anything above it. So it's E0. And then we need to set the base address to be that 80 value at the beginning of the memory viewer, like this. Now let's test this code out. Over here, properties, add a new Gecko code. Paste the code in. Let's put chicken over here. Secret both robos. Invalid read. Okay, let's look at this message. So invalid read from this address. This address is over here. So it looks like the game can't read from this address into the register. So let's go back and look at this memory copy. We're using 8C with this value being F. Here we go. So it's copying from base address plus this value. So the base address is the 8000, but we also put the 8 here. So these two should actually start with a 0. Let's also double check the other one. And the memory copy from register to address is also base address plus the X value. So these also should start with a 0 instead of an 8. So let's try this code now. Go back to part select, set chicken, secret both robos, and swap them. And there we go. So this is just a brief overview of some of the things that are possible with Gecko codes. There's, like I said, a lot of different operations that you can do with Gecko codes for extremely complicated things. AR codes work very similarly, but the actual code type values for most of the code types are different. So for example, the if equal, I think for AR codes, it's like 80. But yes, all the code type numbers are different, so they're not transferable between each other. But the way you go about writing AR codes and Gecko codes is generally pretty similar.